instructions.
Did I misspell instructions already? No, I spelled instructions correctly. Thanks, Matt.
You're welcome.
All right, so your midterm, I was going to give a standard midterm, but I don't like them. So instead, we're just going to have a project instead.
I am discriminated against.
Why is that?
Number one.
Okay, yeah, unfortunately for this project, you can try and get the software running under OS X. I don't think it's going to work.
Bonus points?
Sure, I'll give you bonus points, only if you give me a nice write-up of how you did it. Good luck. Oh, you might actually be able to do that with Homebrew, now that I think about it. Well, anyways, the point of this project is we're going to investigate different programs with different cache coherence protocols.
Brew install Gem 5.
What?
Brew install Gem 5.
That would be funny if that just happens. That would be great. Well, actually, we're not going to be doing cache coherence protocols so much as just evaluating multi-core systems. And then for your final, we'll extend what we have done here to include a couple more capabilities, and I'll ask you to actually modify the simulator. So for this one, it's very important that you actually get very used to the simulator for this midterm, so to speak, and because later on I will be asking you to modify it. Okay, so we want the high idea is that we want to be able to evaluate different multi-core programs on different multi-core systems, and we want to see what parameters we can change on the multi-core systems and what effect that has on our benchmark. So would increasing a certain cache size, would that be beneficial or not beneficial? Do we need to add another layer of cache? Is that going to be beneficial? So forth and so on. So we want to investigate what architectural features that we can add that would improve multi-core performance. Okay. So we got to get a full system simulator, which is what Gem 5 is. I'm going to talk about downloading, installing them. Then you need to get benchmarks. Then we need to do evaluation. So let me go ahead and run through all this. You understand high level what we're doing here?
Yes.
Okay, great. So
I was saying if you can make the text bigger.
Not a problem. How'd that? Let's see if we can get rid of this. How's that?
Yes.
All right. Make sure all your code, you may not have too much, is in the 03 midterm project directory. It is case sensitive. All right. Prerequisite. You're going to need a Linux environment. You can, if you can get OS X to work, I'll give you props, but don't spend too much time. I highly recommend virtualizing Linux Mint or Ubuntu. Either should suffice. If you're running Windows Bash on Ubuntu on Windows, should suffice as well. Although I have not tested it, I don't see why it wouldn't work. You will need to install the correct packages. So when you get your system installed, by the way, when you virtualize, make sure you actually install it to your hard drive and don't do a live boot. You'll be really sad if you try and do a live boot every time, because all your work will be gone every time you reboot. But after you've installed it, we need to get the correct packages. I've gone ahead and listed these out for you.
Is it copy pastable?
Yes. Hopefully these are all the ones you need. If you need more, please tell me so I can update this doc. But these are all the ones I needed. Now you can go to the website for Gem 5. It's actually very Googleable. And they do have a lot of documentation. Some of it is out of date. I'm warning you that right now. But they give you a lot about how to build systems, introductions, source code, etc., etc. But the main thing is clone it, CD into it, and then run the scons command. Warning, this thing takes hours to compile. But luckily you only have to compile it once for the midterm. So
I'm sure it'll take like 10 minutes.
10 minutes on yours? That'd be great. On a Mac, it just magically happen. Yeah, that'd be hilarious.
The trade-off is I gotta spend the time getting it to work.
Yeah. It's very long. Go do something else. You may even get to this point and just click call it a day and go to bed. I'm okay with that. All right. So Gem 5. The Gem 5 is a system call and full system simulator for various architectures. You actually look it up, they will simulate Alpha, ARM, and x86. It can also simulate different types of CPUs, either a single cycle all the way up to a full out-of-order CPU. Just so we can keep a couple things straight. Which one do you think takes longer to simulate, the single cycle or the out of order? Having done your in order pipeline simulator and possibly working on your out of order one at this moment, which one do you think takes longer to simulate?
Going with the experience that I have personally, I'm going with the in order one.
Takes longer than the
Only because I can only speak of my own experience.
No, which takes longer to simulate? Not which one completes faster, which one takes longer to simulate. See, here's the trick, guys. This is why it's a little weird. It's going to take it a lot longer to simulate out of order, even though the out of order is going to complete in fewer time slices because it's out of order. The single cycle is going to take the shortest amount to simulate, but it's going to report back that maybe it took 10 seconds to complete. While this guy, the out of order, will take a long time to simulate, but may report back and only took 1 second to complete. Do y'all see what I'm saying? What I'm trying to point out here? Yeah, keep that in the back of your mind. It's a little weird when it first happens, but that's what's going on. Additionally, if you add cache to the configurations, that does slow down the simulation time, but speeds up the actual how much time it took to complete as well. So you can run the simulations directly in the simulator or booting into a small Linux operating system. Chances are you're going to have to learn how to boot into the small Linux OS and run the programs because this is multi-thread. But if you find a way to compile them for, let's see, system call, syscall simulation, that'd be great, but good luck.
Bonus points.
Sure, I'll give you bonus points if you do that, as long as it's not the pre-built binaries. All right, historically, Gem5 was originally called M5. So when you go through the documentation, sometimes it says Gem5 and other times it says M5. Just keep in mind, it's the same thing. It's just FYI. So now you're going to have to figure out how to use the simulator and run various tasks. Please keep in mind the online help is not up to date. Unfortunately, this is a sad side effect of research. They say, yeah, it works perfectly, and then you go online and find out that that's not exactly the case. They have kept a couple of scripts inside of configs learning Gem5 that actually shows you how they can build a system and run it. And those do work. I've confirmed that those work. You can find some online help from Gem5's website. They got a couple of tutorials about how it works. If you find other helpful material, please tell me. I just want to help people learn this a lot faster because I just picked it up and got going. Excuse me, and it was fine. All right, so that's a little bit about Gem5. Benchmarks. In order to test something, we need benchmarks. You shall use a third party, not your own multi-threaded benchmarks. You must evaluate at least 3 of them. So you can't write your own, you have to find someone else's, and you need at least 3. Okay, Matt?
How about 3?
Keep in mind that for multi-threaded applications, you will probably need to do a full system simulation. If you can find a way to do it in syscall mode, please tell me, but you're probably going to have to do full system. I've found some already out there for you. Splash 2 is historically the standard to use, and that one has 12 benchmarks. So you can just choose 3 from there and call it a day. You can download it from the site. I found a pi calculator that works in parallel. All right, cool. And then Parsec, which is supposed to replace Splash 2, also has about 12 benchmarks as well. So that's 25 benchmarks. I'm just asking you to choose 3.
It's a tough choice.
It is a tough choice. It'll keep you up at night, won't it?
While my thing's compiling.
All right, in addition to the 3 benchmarks, we're going to evaluate 3 different architectures. We have a 2-core system. Each core is out of order at 1 gigahertz with an L1 cache. And the L1 cache is connected to main memory, which is DDR3 1600. There's a way to actually specify that out inside of Gem5. No other caches, and any other configurations are left to you. Keep in mind that with what I'm saying with E is everything is left to you, meaning that you need to tell me what you chose and why. That's all.
So we can arbitrarily choose the rest.
Yes, as long as you tell me why you chose it. Why is it reasonable? Why is that a reasonable assumption to make?
So what would the other configs be?
For example, you have L1 cache connected to main memory. How is it connected to main memory? Crossbar, bus. Why did you choose one over the other? Wi-Fi. Yeah. Why did you choose one over the other? Just as long as you give me an explanation, we're going to be good. I wonder why number 3 got out here. A simple 4-core system, again, it's the same thing as above, except for there's 4 of them. And then the complex 4-core system, oh, I see what happened there. Again, everything's out of order, but we're going to have an L2 cache on top of the L1, and then all processors caches are connected to a shared L3 of size 64 megabytes, and then everything else is left up to you. I had to even specify main memory. There you go. So you have an idea of the different architectures here. Make sure you tell me which configuration options you chose and why. Part of your grade is why you chose certain options. Just keep in mind, as long as you give me a decent explanation, we're good to go. All right. We good with the architecture so far, high level?
I've got one question. If you go back a minute, when you were talking about, no, before that, when you talk about running this as a standalone system,
Yes, so that's when you run in syscall evaluation. So when you call it and run in system call evaluation, you say, here's the simulator, here's my binary, here's the flags to the binary, hit go, it just runs it. In full system simulation, you have the simulator, you have your Linux image, it loads a Linux image, you go into your Linux image, run the benchmarks, and then you're done.
okay, I guess I need to get a little more familiar with it.
Okay. Yeah, they're just go through the tutorial about how to do a full system simulation, and that'll help a lot. Yes? You right, Matt?
You've done this before, Matt?
Nope.
No.
I have no idea what I'm looking at all either.
He just agrees.
What's that?
He said he just keeps agreeing with you.
Yeah. I think he just wants to go home. That's the problem. All right, after you set up your 3 systems and have chosen at least 3 benchmarks, you shall run each benchmark. After each report, make sure you tell me the following: the system you used, aka which of those 4, the benchmark that you ran, the parameters to your benchmark. I need to know what you sent to it. There are default parameters. That's fine. Did you change the parameters any? Why did you change the parameters? Make sure you include total number of cycles, cache hit and miss rate, and then branch prediction / miss prediction. Hey, look, I didn't even tell you what branch predictor you're using up there.
You didn't? I'm using one without 1 entry.
For an inch.
How reasonable is that?
We're trying to cut corners here, man. gotta save costs.
It doesn't matter. You just did and it works. All right. Afterwards, with your initial run, change a configuration parameter of your architecture, aka the 3 architectures up there, maybe your cache size, or you change your branch predictor from 1 entry to something different that you believe would improve performance.
Oh, brilliant.
And run the experiment again, report your findings, and discuss why they were correct or incorrect. aka why your decision, you thought this increased performance, but either it did or it didn't, or maybe it made it worse.
So we can do like the foldy one. Like
Yeah.
The,
Yeah, you just pick something. This is really just get used to this simulator. That's all this midterm is. Helpful hint. When starting, begin with a simple functional CPU, not an out-of-order one. This is what we were talking about earlier. The functional system's a lot faster to simulate. Once everything is running, then when you want to go and run your final simulation, change it to out-of-order. It's going to take a very long time to simulate. But at least you know after you've done your well, yeah, when I did this, I would be like, all right, hit go. See you tomorrow, guys. With out of order, that's what it was. With the functional one,
That much longer, huh?
yeah,
Wow.
yeah, it's a lot longer. With the functional one, it's no problem. It just, hit go. All right, Linux is up. So it's, yeah, just start with functional, get everything running the way you want it to, then hit go on the out of order, and then come back. All right, deliverable, just to make sure that we're clear on what I want from you. It's a final report. Just tell me what Gem 5 is in the introduction. I know, right? You'll probably copy and paste from the website.
Oh, I will. I'll take a
Okay.
screenshot of it. Won't even be text.
Well, Matt, I love how you just keep sinking.
They'll have a logo too.
Explanation of what configuration of each system. Be sure to include what specific choices you made beyond what is provided in this document. Explanation of each benchmark you chose and why it was a good choice for testing multi-core systems. You'll have to research the benchmark a little, and I'll explain that this does a in-body problem, which is very common for simulations. Results from your initial run, explanation of what changes you believe would be good for each benchmark, results from your new implementation. And then part 7, include a section about problems you encountered and what would have been helpful to know going in, aka like something I could add to this document that would help future students
Nothing.
get through this. Wait, I thought you were a hippie, man. Aren't you supposed to help?
Hypocritical.
Oh, hippie critical. Yes, that's it. I keep forgetting. And when did I make this due? March 16th? How much time is that?
Not much.
That is 17 days.
We're going to make that,
19 something.
we're going to make that March? Where did that even come from? We're making that March 27th.
Cool.
Oh, you get a whole month.
That's a lie. It's only 28 days in February. You sit on a throne of lies.
Sit on throne. No teamwork, your work must be your own. So March 27th. Any questions?
So many.
Get back to us like next week after we're like what the
So
heck is
please get started on this. It's going to take you a while to set it up. If you notice, if you think about it, most of this is not architecture, computer architecture problem. It's getting the darn simulator up and running. That's right, I said the word darn. When you have questions, email me or message me on Slack. I will try and help you. That's it.